And welcome to the Friday Forum for June 13th, 2025. This is the 230th Friday Forum in a series hosted by ICLR, the Institute for Catastrophic Loss Reduction. We are Canada's leading source for disaster resilience knowledge. Each month, we present recently completed research related to ICLR's mission to make Canada more resilient to natural disasters. I'm your host, ICLR Chief Engineer, Dr. Keith Porter. I'm speaking to you from London, Ontario, traditional lands of the Anishinaabe, Haudenosaunee, Lenape, and Ottawandaron nations. If you joined us last month, you heard Professor Matthew Bourbonnais of the University of British Columbia tell us about real-time monitoring and prediction of wildfire risk for response and mitigation. In just under 2 weeks from today, on Monday, June 23rd, Robert Robichaud of the Canadian Hurricane Center will give our annual hurricane forecast. And then next month, about a month from today, on July 11th, ICLR's own Dan Sandink and Tamara Mosqueda are going to speak to us. They're going to tell us about a new survey they've conducted that shows that home resilience features have a market value. That is, home resilience features increase resale price by $5,000 or to up to $20,000 and sometimes more. Remember that you can find recordings and the speakers' decks for all of our Friday fora at www.iclr.org/workshops. Now, today, our friend Dr. Connell Miller from the Canadian Severe Storms Laboratory is going to tell us about the Northern Mesonet Project. Connell's team is aggregating weather sensor data from multiple networks across Canada in a single user interface. The Northern Mesonet Project promises a variety of benefits to science and to our audience today. It's going to help us better monitor severe convective storms. Scientists will be able to use this data to improve our understanding of severe weather and climate change. And engineers are going to use it to design better ways to reduce harm to people and property. And I can say this with authority because I use geographic information about weather all the time. And I've already used the data that Connell's going to be talking about today in ICLR's published research. I'm sure that many attendees today are going to be taking notes about how you can use the data that Connell's team is providing for your work. A little bit about Connell. Dr. Miller is a civil engineer and he's the director of the Northern Mesonet Project. He's also an adjunct professor at Western University, and he coordinates the summer undergraduate internship program for the Canadian Severe Storms Lab. His expertise is in the field of remote sensing, drones, instrumentation, and full-scale experiments. Now, before he begins, here's our agenda. Our webinar is going to last 90 minutes. Our speaker is going to present for about half that time. Then I'll moderate questions for the rest of the time. Please feel free to chat your questions into the Q&A box, not the chat box, but the Q&A box. I'll try to pose your questions in the order that they appear in the Q&A box. If we get a lot of questions, I may only pose your first question, then I'm going to move on to others, then circle back to your additional questions. Remember that our webinar is recorded and ICLR is going to post the slides and a link to the video on today or Monday or so. So if you have colleagues who couldn't attend, let them know. You'll find the video and a PDF of our speaker's deck and a transcript at www.iclr.org/workshops. And with that, I will turn it over to Connell.
Thanks, Keith, and thank you for having me. We really do love working with ICLR and all the great collaborations that we do between the Canadian Severe Storms Lab and ICLR. So appreciate the opportunity to speak to you all this afternoon. As Keith mentioned, my name is Dr. Connell Miller. My role at the Canadian Severe Storms Lab is the director of the Northern Mesonet Project. I'm also an adjunct professor in the Department of Civil and Environmental Engineering, speaking to you here today, also from London, Ontario. So this is probably the last group that I need to preach about this, but I do always like to start my slides with trying to tie back what is the actual importance of this? Why are we doing what we do here? And that all comes back to severe convective storms. They're one of the most common and most damaging natural phenomenon here in Canada. And they encompass a lot of different thunderstorm hazards. This can include winds, for example, tornadoes, downbursts, derechos, which is that fun word everybody learned in 2022, etc. There's many different types that I'm not listing here today. Precipitation. I'm sure everybody is familiar with the Calgary hailstorm that occurred last year, but also things like flash flooding. These are real huge insured losses, especially in this category here, as well as lightning. Lightning can generate some losses as well, and are definitely born from these thunderstorm hazards. These losses from these storms are on the rise. Again, probably if you're in the insurance industry, you've probably seen this graph from the Insurance Bureau of Canada at some point. But yeah, a concerning trend with lots of different peaks that from these notable events here. But overall, definitely rising losses. Now, these are for a few reasons. Number one, this is population growth. We're starting to get more and more people. So they're going to, and a lot of these people have insured homes. So that is one reason for these losses rising. Secondly, rising property values in exposed regions. The most expensive properties are the ones on the waterfront or the ones in these idyllic locations that are maybe more susceptible to these severe convective storms. And finally, effects of climate. Now, climate effects are sort of more well understood for some events like wildfire, but for severe convective storms, they're not as well understood. We're still trying to figure out for tornadoes and hailstorms what exactly the effects of climate are. It doesn't help that our database of these different effects has not been historically great over the past few years. So we're, as one of our goals is to try to build up this database so we can actually start to say, okay, what effect is climate change having on tornadoes and hailstorms? You might also notice this big ugly number, which I think is a little off. I think it should be 8.4 billion at this point, but they're still calculating the numbers, unfortunately. It comes from a number of different notable events. This is the Jasper wildfire, $900 million in damages. Some of my colleagues from the Northern Mesonet Project, Aaron Jaffe, Maya Summers, as well as some of our summer undergraduate interns actually went to this event because, as you can see here, there's actually a suspected fire tornado path that went through here. We went from having 0 fire tornadoes ever like occurring in Canada to we documented one for the first time in 2023, and now 2024 we may have potentially found another. So again, starting this documentation of these processes are really helping us to understand how often they occur and what kind of damages that they can do. There was the flooding in Toronto, $940 million in damages. Again, for the first time, the Canadian Severe Storms Lab went out to go assess these damages and try to do a flash flooding survey in Canada for the very first time from any research group, essentially. And then finally, 2024 in Canada, of course, topped off with the Calgary hailstorm, $3 billion in damages, still recovering to this day. I was in Calgary at the end of May, and we actually went around to some of the areas in Northeast Calgary that were still damaged, and still you can see images like that. You could still take images like this to this day. If you take a look at the top 10 insured losses in Canada from severe convective storms, so you've got the Fort McMurray wildfires at number 1, 4.5 billion, the Calgary hailstorm from 2024, Hurricane Debbie, the Southern Alberta flood, the Calgary hailstorm for 2020, the derecho in 2022, flooding, a wildfire, and then Hurricane Fiona. If you start to take a look at these numbers, some interesting trends pop up. Number 1, 5 out of the 10 of these are from what you would classify as a severe convective storm. So again, hailstorms, flooding, tornadoes, derechos, etc. And 6 out of the 10 of them happened in the last 3 years, right? So again, we're starting to see this concerning trend of larger and larger losses, and I wouldn't be surprised if I had to update these slides at the end of this next year because it seems to be happening more and more often. That is why we formed the Canadian Severe Storms Lab, or CSSL for short, with the vision that the Canadian Severe Storms Lab is the authoritative source for severe convective storms research and data in Canada, thereby improving the safety and well-being of Canadians, with a mission to advance the detection, documentation, and understanding of severe convective storms and their impacts across Canada. Now, under the larger umbrella of the Canadian Severe Storms Lab, we have three smaller organizations, some of which I'm sure have presented at the Friday Forum before and you've heard of. Firstly, being the Northern Tornadoes Project. This started all the way back in 2017 when we started doing damage surveys of tornadoes all across Canada with the goal of detecting every single tornado in Canada, regardless of population density or remoteness, by using new tools such as satellites and drones and aircraft to be able to get data about these northern tornadoes for the first time. This sort of spun off into another project, the Northern Hail Project, which started in 2022, again with a similar goal. They are based out in the Calgary region. They're looking for every single hailstorm that occurs across Canada and going out to these storms and actually collecting the hailstones, because hailstones melt, so we have to get there as soon as possible. So we have a chase team out there that goes and collects a hailstorm so we can get accurate data for the first time about hailstorms that occur across Canada. And finally, started in 2024. It launched alongside the Canadian Severe Storms Lab in October of 2024, is the Northern Mesonet Project. Now, I have a branding problem over here because tornadoes and hail are very, very easy to explain. But oftentimes I'll say, yeah, I'm the director of the Northern Mesonet Project. And the first question I get asked is, what is a mesonet? I haven't heard of that. Is that like a wildfire but worse? No, what it is actually, it's a portmanteau, so a combination of words of mesoscale and network. So mesoscale events, these are where all severe convective storms live. They include thunderstorms, tornadoes, downbursts, hailstorms, and they can last from several minutes to several hours. Therefore, we need a network of densely spaced surface weather observations to ensure that mesoscale weather events do not go undetected, hence the name Mesonet. Now, the word surface is very, very important here. You may be familiar with weather radar. You go and you take a look at the map. You see, well, is it raining where I am? Weather radar says yes or no. And weather radar is great for detecting precipitation as well as some other things. However, because of the curvature of the Earth, as you get farther and farther away from that weather radar, you start to miss some stuff that's going on in the ground, especially where a lot of these most damaging severe convective storms live. The worst wind speeds in a tornado are located at the surface. So what we need is a mesonet to be able to detect some of these really severe winds. We started to really notice this when we started analyzing data from the Ontario-Quebec derecho. So this is a map of where some of the worst damage in the derecho was. And what we did is we're like, okay, well, we know there's weather stations at airports and we know where some of the Environment Canada stations are. So let's go and try to grab some of this data to see if we can sort of associate some of these wind speeds with the damage ratings that we're providing across here. The only problem with that is when we started looking, turns out there were issues with the readings, including power outages, some going on beyond the maximum range of the anemometers, and some that were erroneously quality controlled out. So they took the raw data set, that doesn't make sense, and they scratched it out and they gave a different value here because we weren't able to see what the raw data was for ourselves. Now, what we found out later is that turns out there's a lot more weather stations in Canada than just the airport weather stations from NAV Canada and the Environment Canada stations. There's actually over 2,500 surface weather stations located in Canada. The problem being they're divided across many different provincial and federal agencies, and the data from these agencies can vary in ease of accessibility. For example, if you wanted to go look at the data from the government of Yukon, you would have to go to their website, and sometimes, I don't know if this is true necessarily with the government of Yukon, not to pick on them, but sometimes you might come across, oh, I can't actually go graph this data. I can't do this. I have to send an email to somebody to go download the data. This makes it really challenging in two ways. Number one, if you're a forecaster and you're trying to analyze data coming in to see if a severe convective storm is coming through the area. It makes it really challenging to do that in real time because you only have a small subset of that data and not the whole picture. And additionally, if you want to examine the data after a major severe convective storm, there's problems with that as well. As we talked about, sometimes the raw data will get quality controlled and that quality control may not necessarily be correct, or it might just disappear because the data logger sort of loses power and erases it, right? So that is why we wanted to start the Northern Mesonet Project with the main goal of connecting and enhancing Canada's weather networks. And we're doing this in two ways. So the connecting portion, we'll talk a bit in a second about the Canadian Mesonet portal, as well as our own series of weather networks that are specifically designed to capture data from these severe convective storms. So we'll talk a bit about the Canadian Mesonet portal. Before I continue any further, I should mention that a lot of this work should be attributed to some of the undergraduate interns that I supervise, specifically Colin, Min, and Josh. All three of them have done fantastic work to get this thing up and running. I am not a software engineer or a computer scientist, so I can lead the charge, but I can't physically sit there and help them code anything. So a lot of this credit should go to them. But what is the Canadian Mesonet portal exactly? So it is a network of surface weather station networks. It's a network of networks concept again, right? So what we're trying to do is like, okay, well, we have data from these 30 different spots. Let's put them all together and see what we can do with this. So I'm going to give a brief demonstration here of the capabilities of the Mesonet portal here. So hopefully at this point, you are seeing my screen with the Canadian Mesonet portal. If not, Keith, you can feel free to stop me here. So right now you can see that the Canadian Mesonet portal is registering 2,825 stations all across Canada here. They're represented by these black dots here. But as you zoom in here, you can see that you start to get a bit more information. So this is live weather across southwestern Ontario right now. So you can click on here and you can get a graph that provides you with weather information. There are a couple filtering tools that are available for you. For example, you can see we've listed all of the 30 different networks that are available. So if you're looking and you want to say, okay, well, I only really want to see the airport stations, maybe mixed with Environment Canada stations, and then let's throw the Ontario Ministry of Transportation stations in there. You could do that. You could also, for example, well, there's a lot of precipitation stations out here, so maybe I only want to see the ones that are actually reporting wind. You can do that. You can say, okay, well, I want to see that, so only the ones that are reporting wind can show up. Maybe you're doing nowcasting and you say, okay, I only want to see stations that have reported values in like the last 30 minutes. You can do so there. It looks like pretty good. Most of these stations have reported in the last 30 minutes there. We also have a quality control check here. So you can report the broken stations as well as the doubtful stations. Right now, they're automatically hidden, but you can choose to not hide any of them or hide the doubtful stations, which we'll talk about a bit in a second here. There are also filters that you can put on top. So for example, we have the GOES satellite here. So you can enable that to see where the clouds are in the area. You can also change the opacity of that, right? So if you just want to see it a little bit there, you can do so. We have weather radar. So you can see, oh, it looks like there's potentially a storm coming in southwestern Ontario there. So you can see the weather radar is providing you with that information. We also have lightning density, weather alerts. Don't know if I'm sure there's a weather alert somewhere in Canada here. There we go. So you can click on that. There's apparently a frost advisory going on in Northern Ontario there. So you can see that. We also have some specialized tools here, one of them being the mesh product. So the mesh product, what that does here is it gives you the maximum estimated size of hail based off the dual pole radars that are available here. So you can see in the States here, it looks like they've gotten a pretty significant thunderstorm here that may have produced some hail. You can go to our legend here, and it will show you the legend. So it looks like over 100 millimeter hail there, which is actually quite significant. You can also, while you're on here, you can make a 3D version of that. So if it's helpful for you in any way to see what the exact numbers are, you're able to do so there. Finally, there are other ways that you can view this station data. So for example, I'm just going to pull this back over here to our Southwestern Ontario view. So for example, if this is all too complicated for you and you're just looking to display something very specific, you would be able to go here. And right now this is set to like WMO standard. So you can change it to temperature there. And what that will do is it will give you, I'm just going to make sure that only stations with temperature are displaying. As you zoom out, you'll see you'll get color bars here that indicate where the coldest areas of Canada are. The other thing that I will mention is that you're able to search for stations here. So if you search for a station there, it'll bring you to it and start graphing that data. I'll expand that here just so you can see a bit better what's going on. Over here, you don't have the, or sorry, you have the ability to do more than just air temperature here. So you're able to click on different variables here and see what they're reporting. So you can report up, or you can view up to a week's worth of data here. You can see, you can hover over it to see what the exact values were at that time. It'll also give you the average, the high, and the low for whatever area you've plotted there. You can also do different averaging values. So this is giving you the 2-minute average wind speed. If you want the 10-minute average wind speed, you can do that as well. You can also click and drag if you're interested in a specific instance in time to be able to view that there. And then you can add multiple charts. So if you want to compare things on top of each other, you can do that. So if you want to compare the wind speed to the wind direction, you're able to do so here. There's also info bubbles that will bring you to our website to give you a bit more information about the specific networks. These are a bit bare bones right now, but we're going to be working on building this out with the metadata of these stations. So what exactly instruments they're using and what data are they collecting and how often. I think that's all I'll mention about this Mesonet portal. Oh, one more thing I will mention here. So let's say you're doing some forecasting and you're happy exactly with the view that you've got and you want to be able to return to that view. You have an export button here. What that will do is it will give you a special link that you can bookmark. And as you go back here, it will bring you back to that exact view that you left off, right? So you can create multiple bookmarks to say, okay, I want this specific view for Southwestern Ontario or this specific view for the prairie. So it's really, really meant for this portion of it. It's really meant for forecasters to be able to use this efficiently for forecasting. So coming back to my slides here, so currently the Canadian Mesonet portal is the only way in Canada to view all of this data in real time. It's also soon to be the only way in Canada to bulk download from all of these stations with all of the historical data that we have. So to do that, we have to develop some things in the future here. So one of them being our historical view. So this feature would enable users to view surface weather maps from any past time instead of just the live view of the past week that is currently available. Currently, this goes back to when the Mesonet portal started collecting data in November of 2024, but we'll be working with Environment Canada to backfill even more historical data beyond that. I didn't really have much more to show about this, but 20 minutes before the presentation start, Josh and Min sent me the latest update to the Mesonet portal, which isn't live yet, but I'll give you a brief demo here. So what you can see is we have this time bar at the top that will allow you to flick through and see how the surface weather map is changing over time. You can also press this button and select the date and time that you're looking for here. So for example, let's go select somewhere cold in February here. And you can see once it loads, there we go, that you have data from that time period. So you can see it's not, obviously not -8 degrees Celsius right now in southwestern Ontario. So yeah, that's how we're able to show some of that. And that will be coming live probably in the next few weeks. Some more upcoming features, Canadian severe weather summaries. So this will be a daily interactive map that summarizes severe convective weather from the previous day. This will include some of the radar products like rotation tracks and maximum estimated size of hail, which will really indicate where potential tornadoes and hailstorms occurred. It will also include lightning observations as well as surface weather observations. So we have all these stations, so we'll display only ones that indicate that a severe convective storm went through that area. So winds that exceeded 90 kilometers an hour, for example, or precipitation rates that exceed 5 millimeters an hour or 10 millimeters a day. Some more upcoming features is quality control. So we're already doing this quality control here, and a lot of it's provided by Environment Canada. So you can see on when you're hovering over there, it'll either give you a green dot, an orange dot, or a red dot for whether the station is providing good quality data, bad or doubtful data, or bad data. Now, the problem is, so Environment Canada provides a lot of these flags, but they don't say why they're providing a lot of these flags. So we're working with them to be able to implement that into the Mesonet portal so that we can show there's a flag and why is it throwing that flag. This is going to be really important for when we start to be able to provide downloadable data for people so we can actually provide as part of that Excel sheet or CSV or JSON or however we end up doing it, that there was a quality control flag here, and here is the reason, which would be the first time a Canadian data set has been able to provide that. We're also going to be using stations that are located near one another from different networks to automatically flag stations for quality control. So the benefit of actually having these stations talking to us for the first time is if we have one station that's located beside another, we can actually see if they're reporting similar enough, or if someone needs to go in and manually take a look and see if one of the stations is reporting erroneous data. Later on in the summer, we'll also provide an advanced Mesonet portal. This will sort of be an advanced dashboard for advanced users that's going to be able to provide a few things. Number one, an advanced station overview. This will be sort of a dashboard which provides information on which stations across Canada are reporting quality control flags and for what reasons. So instead of having to manually click on each one to see if it's reporting bad data, it'll just give you a list of the stations that are reporting bad data, which a lot of the networks that we've talked to about this is one of their most requested features. It'll really help them to take a look and monitor their own network, and in so improving the quality of weather data across Canada. Number two, supplementing data. So we're going to be enhancing the weather station data with information that is not typically provided by the networks. So I've already mentioned one of these being the quality control data, as well as lightning strike data. So being able to take some of that lightning observations and say, okay, there were lightning strikes, this many lightning strikes at an average this far away from each station. So we're not only taking in the data, we're actually adding and appending on to these data with more information about lightning in the area. And finally, severe weather data. So we have our Northern Tornadoes and Northern Hail project. So the goal is to, once they confirm a tornado or a hailstorm, being able to add that to the data for the weather. So you'd be able to filter through and say, okay, I want to see from this tornado what weather stations were reporting. So being able to do that and appending that onto the data will be really, really helpful for people trying to get weather station data specifically from different storm types. We're also looking to have downloadable data. So this would allow for users to download data while being so you wouldn't have to download the entire however many gigabytes or terabytes this ends up being. You'd be able to request data from specific dates and times or specific storm types or specific networks or specific variables. So if you only wanted like air temperature or something, etc. I will mention too, this version of the Mesonet portal will not be open access. The current version of the Mesonet portal, meso.csl.ca, is open access. This one, you will have to have an API key to access. The reason for this being is just, we don't want people downloading our data over and over and over again and crashing our servers. We want to be able to have a conversation with you, especially if you're using it commercially, to be able to say, okay, what are you using it for? What do you need, et cetera, right? So that we can best provide information for whoever needs this advanced sort of information. So that's all about the Canadian Mesonet portal. I'll also mention about our own network of stations that we have the acronym STORM for, which stands for Severe Thunderstorm Observation and Research Mesonet, because if you don't have a good acronym for something as a research project, why are you even bothering? So the goals of STORM is to provide the best possible surface-based observation for severe convective storm detection and nowcasting, and specifically to evaluate specialized instrumentation built to handle extreme weather. As you can see, we're shooting a hail cannon here at one of our hail disdrometers as a test for it, and to evaluate the utility of a surface station network built specifically for the evaluation of severe convective storms. And the one network that we have out there right now is our hailstorm network. This was, again, with a collaboration with ICLR to put these stations out. We put them out across the Rocky Mountain foothills region, specifically 21 stations in Calgary, as well as 8 stations east of the Rocky Mountain foothills. They're located at fire stations and stormwater management sites, and most residential and commercial areas are within 4 kilometers of a station, so we're fairly happy with the density of these stations across Calgary. It's composed of 2 sensors. The first sensor being our all-in-one weather station, not necessarily the most groundbreaking piece of technology out there. It's more to just get a sense of what weather is going on in the areas. But more importantly, and what is more of a groundbreaking piece of technology, is our hail flow sensors. So this is a hail disdrometer. It's essentially a glorified microphone where hail will hit the top of the metal plate and that will register a sound. And what we can do is convert that sound into not only detecting how many hits that plate received, but as well as a distribution of hailstone sizes, because unsurprisingly, the bigger hailstone that you have, the louder the sound will be when you hit it. And again, this is part of the reason we actually needed this Mesonet portal in the first place. It sort of started from, well, we need a way to display our own data here in terms of this specialized hail distribution data that was, there's no like real standard way to display this data. And then it just sort of grew from there to being like, well, if we're displaying our own data, why don't we go and display all the data, right? So that's sort of where the inspiration for the Canadian Mesonet portal originally came from. We're also in the midst of validating this data because we're not just happy with, yeah, I mean, this is a bit of a black box of an instrument, but I'm sure it's fine. It'll work. But we want to be able to validate that as well. So we're doing that in a few ways. Number one, we're putting them adjacent to some Alberta agriculture stations so we can compare with well-known sensors. Number 2, we're going a bit old school here. We're using hail pads. So what we'll do is we'll put these hail pads out beside it. It's essentially just a piece of foam that as hailstones hit them, they'll leave a dent. But what we're doing with this is we're using machine learning to then detect where these dents are and to be able to automatically get the distribution from that. We used to do this by hand. It was a terrible process. So this is what the inspiration was for trying to automate some of this analysis here. And again, we're really, if you give an undergraduate student a project, it's really amazing what they can do sometimes with this. So this was another undergraduate student, Kevin Manka, who is actively working on this currently to be able to take these 3D scans of the hail pads and use different thresholds and algorithms to be able to get a histogram of the dent widths. The other thing we're using trail cameras. Turns out trail cameras are actually pretty effective in being able to detect when hail is falling on a surface, because what they do is essentially they take a picture as movement is detected in the area. So you can see hail starting to form. We put like a turf pad out there so that it sort of absorbs some of the impact so they don't immediately just bounce out of the area there. And literally, so this is an hour later, you can see that the hail has pretty much completely melted at this point. So you can see why we're going to these lengths to try to capture some of the hail data, because it turns out it's quite challenging to do so. We also capture a fun number of different pets, animals, birds, and that sort of thing. I always like showing this picture just for fun. Um, and we're starting to collect data from significant hailstorms. So you can see one of our stations was directly in the path of the 2024 Calgary hailstorm, and we're starting to get some data in terms of the hail diameter as well as when the storm actually occurred. You can see most of the storm occurred within a 20-minute period, over 450 hits sometimes in 10 minutes. And you can see the hail diameter not actually super strong. Most of the register was around that 5 to 10 millimeter region. That just goes to show that it really doesn't take a lot for hailstorms to damage vinyl siding. If I had my way, vinyl siding wouldn't exist. We would use better materials, but alas, here we are. We do have plans eventually to put more networks out across Canada. The two that we're currently targeting right now is a wind network, specifically in southwestern Ontario, and a flash flooding network, specifically in the city of Montreal. And I'll talk a bit actually about the wind network, because we've started putting in grant proposals and we've started really thinking this through. And what we're hoping to do is to put in a 3D mesonet for the first time, both in Canada and the US, here in southwestern Ontario. So this is our view of our wind monitoring stations across southwestern Ontario currently that exist. I'm just going to simplify the view here a bit so that all the wind barbs aren't getting in the way of things. If you overlay the Northern Tornadoes Project data on here, so this is where all of our tornadoes and downbursts for the last 7 years have occurred at this point. You can see we've got some concerning gaps here, where a lot of these tornadoes and downbursts occur, but we don't have a whole lot of stations to really back that up and measure the data. So that is why we want to put a mesonet in there in the first place. So if we had our dream goal, what would we put in there? Well, the first thing is our standard mesonet station, designed with instrumentation that is specifically meant for severe convective storms. So we're talking about anemometers that can handle 300 kilometers an hour. We're talking about rain gauges that can handle up to 100 millimeters an hour, and that sort of thing. But terrain is complicated, right? Even if you put the nicest stations there and you've got it in the perfect location, there can still be a lot of effects that are really, really challenging to overcome when you're trying to forecast these severe convective storms. So we have two other things we want to put out there that kind of make it more of a 3D mesonet instead of just a point in space that we were able to see. Number one is a pan tilt zoom camera in 4K that's able to actually see the storm structure as it coming in, which is really helpful for our forecasters. The other thing we want to put in is drones. So you're thinking, okay, drones, they're great for taking pictures. What use is that going to do? But what drones can actually do is we can put meteorological instruments on top of them and send them up a kilometer or two into the sky and be able to get soundings from them. So these drones would have temperature sensors, humidity sensors, wind sensors on them, and we would send them up hourly to be able to get these full picture of what is going on while a severe convective storm is approaching. And these soundings and these photographs are really, really important for forecasters to be able to get warnings out ahead of time, especially because if you take a look at the current state of how we get soundings, so this is where we get soundings from in Canada. The white circles, we get them twice a day at 0 Zulu time and 12 o'clock Zulu time. The green stations, they sometimes launch erratically. And so, again, twice a day. And these are getting more and more expensive because of helium costs, unfortunately. At this point, they're not exactly the most environmentally friendly. So instead of having 20 or so things that go up twice a day all across Canada, we'll have 10 of these sort of instruments that are really densely in southwestern Ontario and really meant for detecting and nowcasting severe convective storms. The other thing I'll mention of how we try to also get 3D data, there is currently a southwestern Ontario LiDAR mesonet that does some of this, but there are some problems with that. Number one, that they're not exactly located in spots that were missing instrumentation. Most of them are in the GTA. Number two, so these are LiDAR-based sensors, so they require things to bounce off of, right? So if it's a really dry day, you're not going to get great results from this, and you're also not even going to get temperature or dew point or any of those things that you can use to make those traditional soundings from that. So again, that is why we're aiming to put in this network in Southwestern Ontario specifically. Thank you for listening to my presentation. I really appreciate it. I'm happy to take any questions, but I've also put the website for both the Northern Mesonet Project as well as the Canadian Mesonet Portal, which again, completely open source, completely open access, as well as my email if your question for some reason is unable to be answered during this Q&A.
Awesome. Thank you so much, Connell. That was a great, exciting presentation. My first note was to add cool video to my decks like Connell's title slide. I got to take a leaf from your deck. We don't have any questions yet, but I have many. First of all, another comment. You added a new term to my vocabulary, fire tornado. Is that an existing term of art that other people have used? Have we seen fire tornadoes like in the LA wildfires of January? Is that a thing, or is it a new?
Yeah, it's not a new thing. This I would say it's a not well documented thing. So there's a difference between what we'll call a fire whirl and an actual fire tornado. A fire whirl can happen really easy if you have a forest fire and the wind just kind of picks up because hot air rises and you've got all the trees around. So you can get fire whirls easily from that. But what a fire tornado is, it's a more destructive actual tornado that requires a severe convective storm to be over top of a wildfire and actually generate a tornado like you would see elsewhere, essentially. So very different. The fire tornadoes are much more rare. Again, we've only officially documented one in Gun Lake, British Columbia in 2023, but we're also looking into a few other cases, both from 2023 and 2024. They're just very hard to document, and no one's really ever tried to document before, so we're running into a lot of challenges.
Cool. You also seem to say that a hurricane is not a severe convective storm. That's something that I hadn't picked up on before. Did I mishear you?
No, I don't think I said a hurricane is a severe convective storm. In fact, I think when I showed that slide, I didn't highlight that hurricane as a severe convective storm. Severe convective storms are usually associated with thunderstorms, right? Which a hurricane is not.
Okay, that's what I said, that they're distinct things. I did not realize that they are distinct things. Let's see. You showed the meso.cssl.ca dashboard, which is the Mesonet portal, which is really cool and really powerful. And cool, powerful platforms like that can be a bit overwhelming for at least when people see them for the first time. Can you tell us, what do you think, what's the most popular use that you've seen so far of the Mesonet portal?
Yeah, so the most popular use I've seen so far is storm chasers and forecasters using it as a nowcasting tool to get closer to tornadoes and hailstorms. So our hail team actively uses it because surface weather is really important for trying to forecast where hailstorms specifically are going to end up. So that is the use that we've seen before. Admittedly, we've also had some interest from different insurance agencies about the historical data as well. So that's why we're sort of putting a lot of focus into that right now, both for like viewing historical data, which is also helpful for researchers if they're trying to look at the surface weather from a storm that's happened years in the past. But as well as trying to get risk analysis done on these different severe convective storms.
Which is how I use it. What do you think is the most scientifically consequential use you've seen so far?
The most scientifically consequential use I've seen so far. I think the problem is that it's so new that like again, we just launched this in October. I haven't seen any like research papers that have
Right.
used this before. But we're going to start once we get this historical viewer done. I'm personally working on a paper on the Didsbury, Alberta tornado that happened on Canada Day in 2023. And I think it will help going back and looking at an analysis of what was forecast and how was the storm forming and what did the surface weather tell us on the surface that maybe we missed because we didn't have access to it in the future or in the past.
Cool. Have you set out, have you had to define sort of limits to the Northern Mesonet project? Have you decided, has anybody said, oh, you should be collecting this, that, or the other kind of data? And you said, no, that's outside of our scope of work, like, you know, damage information and I don't know, fire information. Have you had to set the boundaries yet?
So far, no. I keep coming up with ideas and we keep just moving forward ahead with it. The only no that we've sort of given so far is for American data. We immediately sort of got interest of like, can you add American data to this? And we said for a few reasons, no, just because of it's harder to form a relationship with them to be able to get some of their metadata and things like that. And eventually, we really want to display what metadata is there. So researchers can say, oh, they're using this type of rain gauge, right? And I need to account for that in some way.
Okay, cool. We have a couple of questions from attendees. Dave Baylog asks, what are the costs of accessing your site? What do you
Uh,
charge?
free right now. So the meso.cssl.ca will always remain free. We at the Canadian Severe Storms Lab, we really pride ourselves on open data. So all of our tornado data is free to access. All of our hail data is free to access, and this data is also free to access. That being said, we do have a Creative Commons license on it that relates to commercial data that it's not permissible to use for commercial data, and that if you want to use it for commercial data, you need to reach out to us in some form.
Cool. Um, Sherry Steiginga or Steiginga asks, I noticed that precipitation isn't a parameter listed on the portal. Did I miss it, or will it be on there in the future, or is it left out on purpose?
You might have just missed it. We definitely do have precipitation on there. I might have just clicked on a station that didn't have a rain gauge on it. So not every station will have precipitation. That being said, there's definitely precipitation and snow depth values that are available there. Essentially, we took every variable that weather stations report that are even semi-remotely useful. Like I don't think we put battery voltage in there or anything like that. But any actual like meteorological measurement is in there if the station provides it.
Okay, cool. Let's see. Um, Johanna Brady has raised her hand. Johanna, I've got to ask you to type your question into the Q&A box. We don't unmute people, so you can ask your questions. While you're doing that, Johanna, I will ask another one. You spoke about two networks that you want to add in Southern Ontario. Does the broader community have a consensus of, I don't know, gaps across Canada for instrumentation, either, locations that are generally under measured or types of instruments that are that we need in Canada?
Yeah, so those locations that I showed that I drawed out, that wasn't just me that came up with like, oh, I think the gap is here. That was in consultation with Environment Canada. It was in consultation with forecasters and storm chasers in the area that have identified those gaps. So we do have we do work with Environment Canada for a lot of this. You may have noticed that some of that quality control stuff, we would have no idea how Environment Canada does that if they hadn't provided an Excel sheet with 1,000 rows on it that we're working on implementing onto the back end. And they said, well, we're never going to implement this or show people this, but if you want to do it, you can go ahead. So we do work with a lot of different groups to try to pilot the best way forward.
Awesome. Thank you, Johanna. Johanna Brady asks, I noticed that on the Northern Hail Project, it notes a future objective of looking at future implications under climate change. Can you talk about this? She's noticed most climate data providers do not include hail and ice storms. Are these projections more difficult to make?
Okay, I'll take a shot at this. I'll give the caveat here that I am not the director of the Northern Hail Project. I would encourage you to email nhp@uwo.ca. That'll bring you to Dr. Julian Brimelow, who might be able to answer this question better. That being said, in terms of climate data providers not including data on hail and ice storms, that is a gap that we've noticed. The last major project that occurred in Alberta that detected these ice storms happened many, many, many years ago, and then it just sort of stopped. And then now we're trying to pick it back up here in 2022. But what we're trying to do is create that data set of climate data and surface weather data that does include hailstorms that occurred across Canada. So we're trying to create that data set for ourselves because we do recognize that these data just don't exist currently. In terms of projections, I'll probably just refrain from commenting on that as I'm not the hail projection expert.
Okay, well, then you may not be able to answer my next question, which was raised by Johannes. And I noticed in the August 2024 Calgary hailstorm, and as you pointed out, you had an instrument right in the hail swath, but people always want more, right? They want denser instrumentation, and I wanted to see hailstone size as measured by disdrometers elsewhere in the hail swath. Presumably that would be just prohibitively expensive, but how dense ought a disdrometer network to be if we want to understand hailstorms better?
For sure. So I admittedly I only showed one station. There were a few stations in Calgary that did get hit, but for simplicity's sake, I just showed one.
Mm-hmm.
That being said, it's really a money question, right? In terms of like, not only do you have the upfront costs for the instrumentation, you have the cost of maintaining that instrument, you have the cost of getting that data over a cellular network to the actual storage there. You have the cost of maintaining the storage. You have the cost of providing a data portal, which we're currently providing for free, but there were like costs associated with like developing that portal, mostly salaries and things like that. But I'm sure at some point we'll have to buy a bigger server to like keep storing all of that data, right? So there are costs associated with that. Obviously, the denser the better, right? But the reality is the network in Calgary is already pretty dense. It's probably one of the most dense mesonets in Canada. I refrain from saying it is because I'm not 100% sure. I know the Manitoba Agriculture Mesonet has a good amount in Manitoba as well, but for an urban area, for sure, to have 21 stations in Calgary is almost unheard of. So we're already trying to be as dense as possible. That being said, if someone has spare money kicking around, we'll never say no. We'll put more stations out there for you. Sure, why not, right? But
And there's other practical limitations as we discovered when trying to place those disdrometers. It
yeah, so
can
we
be
it took a
challenging to secure the real estate.
yeah, it took a very long time to work with the city of Calgary to be able to find these locations in a way that was suitable for them and suitable for semi-suitable for us. There's still some challenges there that I won't speak of, but yeah, you have to find partners that are willing to work with you as well. Or if you don't, you have to pay for real estate to put these stations out there, right? So lots putting a station network out there is not easy. When we started like when we were first like kind of ruminating on the Northern Mesonet project before it launched in October, like we started thinking about it in January, and our first thought was thousands of stations across Canada, and then we started costing that out, and we're like, No, that's impossible, like just logistically impossible for the size of group that we have at the Canadian Severe Storms Lab. So that's why we pivoted and said, okay, well, we have all these stations out here and we know how to access them, but we can't access them all together. And there are some deficiencies there that we think we can solve. So that's why we started with this Mesonet portal concept. And then hopefully slowly over time, we start building out specialized networks for these severe convective storms.
Yeah. Matteo Di Stefano asks, I noticed rainfall gauges operated by only some conservation authorities in southern Ontario are on the Mesonet portal. Is this an ongoing process, and will there be more stations to come?
Yes, this is an ongoing process. Again, we just launched in October, so we're getting stations in. It's not a fast process in terms of like working with these different organizations to be able to capture this data in. Um, Environment Canada as well has a collaborative monitoring group now that is also working towards that same goal. So the strategy we're sort of taking as we work with Environment Canada here is to let Environment Canada focus on getting these stations into their network, which then will provide a front end for that. That being said, we're also trying to find these networks and bring them to Environment Canada to help with that. And we do have some networks that aren't directly associated currently with Environment Canada in there. So if you have recommendations for station networks that you think should go in there, we're more than happy to bring that in and start putting that in. And then if Environment Canada does it themselves later, we'll take off our version of it and support their version of it. The other thing I'll mention too, in terms of stations, is we're actively trying to get stations from the Citizen Weather Observers Program in there. So these are citizen stations, but they're stations that go under really heavy quality control checking there. So we're going to be able to provide that as well, which will likely provide another 500 or 600 stations across Canada. And then it gives us a way to say, there's been a few citizens that have said, hey, can I put my station on there? It gives me an avenue to say, well, if you can get it to qualify for this program here and go through that, it'll automatically start appearing on our portal.
So first of all, Matteo, so you're seeing Connell's email address down there at the bottom. So if you've got suggestions, Connell, it's okay if he emails you. Okay, awesome. You and I have spoken in the past about human observations, people picking up hailstones and measuring them and telling you where they are and how big they were and so on. Is that on your? Are you thinking
It's
about?
on my radar, but admittedly, it's pretty low on my radar. We have so much that we want to do with this, as you can see,
Yeah.
that it eventually it would be good to have some sort of like reporting system that works through the Mesonet portal for both tornadoes and hailstorms and sort of put that all onto one thing and then be able to have a layer that shows like reports from people coming in as like a separate layer that people can toggle on and off. That being said, it's not 100%. It's not 100% as a top priority right now, but maybe in a year or two.
We're still waiting for more questions, but the soundings with drones, that was really interesting. I know that the Canadian Severe Storms Lab is working with who are you working with? You're providing sound anyway, balloons.
Yes.
But this is entire. But this business with drones, is that cheaper than balloons? Is that something that could be rolled out very broadly? Have people been doing soundings with drones for a while? Give us a little bit more of that story.
Yeah, sure. So the upfront cost is a bit more expensive. That being said, with the cost of helium and the cost of radiosondes going up, you essentially only have to have the drone operational for a year to match the same cost as running weather balloons for a year. And then it's more cost efficient in that way. There's some other benefits I'll mention too. So weather balloons, once they go up there, they can drift and move around there. Whereas drones, you can geofence it so it stays within the same 20 meters. You're actually getting like a perfect vertical sounding going up into the atmosphere there. That's not to say there aren't some challenges with using drones, and there's reasons that people haven't immediately moved over to this new technology. One of them being Transport Canada restrictions. So Transport Canada really heavily licenses drone use. You can only go up to 400 feet right now, which obviously is not really high enough for a sounding. That being said, there are special flight operation certificates you can apply for. I personally and many people at the CSSL have advanced drone certificates and will soon have our drone certificates for the Beyond Visual Line of Sight complex certificate when that releases in November. So I think the CSSL is uniquely positioned to both have the drone expertise as well as the meteorological expertise to make this useful. Because Environment Canada is sort of exploring this as well. And when I sort of talked to them, and I was like, well, what about this for like drone restrictions? And they're like, oh, I've never flown a drone before. I didn't realize that was a thing that we would have to overcome, right? Um, and we've applied for many, like we have a good relationship with Transport Canada. We've applied for many special flight operations certificate before, so I'm confident after a bit of work we'll be able to do this, right? We're planning a bit of a phased approach here. So I showed you the like big network idea that we have, right? But we're going to start with buying one, and we're going to use them with the hail project, put them in front of hailstorms, and get soundings right before hailstorms come in to see, A, are we happy with the data? Like they say that it's just as accurate as a traditional radio sonde, but obviously we want to test that before we agree to that. And two, to see like how useful this is to actually do this concept before buying 10 or 20 of them to put a network out across southwestern Ontario.
And I suppose a sort of AI controlled robot drone that nobody's controlling. You just program pop up every hour, then fly back down, recharge, pop up. That's in the distant future, I suppose.
No, that's the concept. That is the concept for. So the one drone that we have, that would be a mobile drone that wouldn't have like a recharging station. But the drones I'm talking about for this 3D Mesonet have a base station that it like opens up the lid, you launch the drone automatically every hour, and then it comes back down to its recharge station. The box closes up, it recharges the drone, and you go again, right?
Without a pilot, without a human pilot.
Without a human pilot. You would have a pilot monitoring it remotely, and hitting the button to go essentially, but you wouldn't have a pilot directly there at the station.
So that really scales very easily. You just buy more apparatus and place them. You don't have to.
Yeah. Again,
people.
the biggest challenge for that will be getting the approval from Transport Canada to do that. But I 100% believe that this is the future. Some countries have already started to do this, like Norway. They have a network of 30 of them to help with their airport weather. So I truly believe this will happen eventually, but I think the CSSL is the research group to get it going in Canada here.
But the programming is all done, and it's the concept is proven. You just have to take the technology and implement it in Canada.
Yeah, the technology is there. We just have to implement it.
Cool. That's super exciting. I didn't know about that. Let's see. We don't have any more questions. I guess I have another one. Can you tell us how tightly your terminology and your iconography and all that other stuff aligns with other countries, with the United States? Is your Mesonet project going to be able to communicate and exchange information easily with others?
Yeah, all the technology I think is pretty standard. I would say, again, I think it was just a matter of someone going out there and having the vision to do it rather than it being like a groundbreaking piece of technology. There's a lot of work that we put into there to making it fast and efficient, and you don't have to sit there and watch it load for an hour as you're trying to load in all the data. So there's some uniqueness to that. That being said, like the terminology we're using is standard. The symbology we're using is standard. People go like we consulted with all the meteorologists on the team to say does this make sense? Is this what you expect to see in a typical surface weather analysis? How can we make this better for you? And that's driven a lot of our R&D for when we were building this.
Cool. I do have one more question. How long are you funded for?
10 years. So we are funded as part of the Canadian Severe Storms Lab. We have enough funding for the next 10 years, and the Northern Mesonet Project is a line item in that. That being said, we're actively pursuing other funding opportunities so that this thing can continue on ad infinitum.
So if we have attendees in the room today who would benefit from an expansion or a continuation, they should reach out to you, right?
Yes, absolutely. We're happy to work with different agencies. We've worked with like people like solar farms that want to know weather information as they're coming in so they can change the angle of their solar panels before a big hailstorm hits and things like that. If you are interested in weather stations or you think there's a need for that or the data, we're happy to have a conversation with you. And we are definitely actively having conversations with reinsurance agencies as well.
Cool. Exciting. Well, Connell, we don't have any more questions, and I've
Okay.
given you all the ones that that I had that are worth asking. Do you have any final words for us? Any? Do you want to leave us with one final thought?
One final thought. I think that what we're doing here as part of the Northern Mesonet Project is really, really critical for getting weather data to Canadians in a more accurate way, in a more accessible way, and in a way that will help protect them from severe convective storms. So I'm really excited to see if I gave a presentation on this 10 years from now. I'm very excited to see where this ends up going. And I think, Keith, you mentioned earlier that one of the biggest changes to like detecting earthquakes was when we started getting all of these networks and putting them together in a single box to
Yeah.
be able to use big data to help solve these problems. And I really hope that this is a similar sort of outcome for severe convective storms.
Yeah, I think it's got to be. I mean, the seismology made huge leaps forward once multiple networks were connected together.
Mhm.
It made a huge difference. Okay, so Connell, thank you so much for a great talk and a fabulous deck, I have to tell you. And congratulations on doing a live demo, in front of an audience, and nothing went wrong.
Excellent.
That was
Glad to hear it.
that's always amazing.
Yeah.
I want to remind everybody that Connell's deck and the video and a transcript of today's talk are going to be posted within the next 24 hours or so. Maybe by Monday, maybe on Monday at www.iclr.org/workshops, and remind you that we have two webinars coming up. Our regular next Friday forum on July 11th will be Dan Sandink and Tamara Mosqueda of ICLR telling us about the market value of resilience features in homes. And Bob Robichaux of the Canadian Hurricane Center on June 23rd, Monday, June 23rd. Bob Robichaux is going to be giving our annual hurricane forecast. So I hope to see everybody in 2 weeks or a month or whenever you care to come back. Thanks, everyone, and have a great weekend. Bye-bye.